Look out everyone, I'm Anurag from K7 Labs and today I'm here to deliver the message that Outlook's gonna get you. So as the title suggests, in this presentation we will be discussing about some vulnerabilities that were reported in Outlook, that were exploited in the wild, and a lookout for the future. So let's start. Well, Outlook actually needs no introduction, but just as a custom, Outlook is a email client with one of the highest market shares, and it comes packed with MS Office suite. At the back end, Outlook is supported by Microsoft Exchange Server, which as we all know was target of multiple vulnerabilities back in 2021. But why sudden interest in Outlook? Microsoft patched a vulnerability back in March this year, which caught everyone's attention. And when we started looking at it, we realized that Outlook could be a juicy attack vector for threat actors. So here is a list of some of the vulnerabilities that were patched in Outlook since 2021. And the one highlighted in red has been exploited in the wild, and we will be discussing about that in this presentation. And not only Outlook, other Microsoft Office applications have also been targeted. And this table shows some of the CVEs that were reported in MS Word, MS HTML and Outlook. And the ones highlighted in red are the vulnerabilities that were exploited in the wild. So recently we have seen a trend where threat actors are moving more towards exploiting Microsoft Office vulnerabilities. So let's quickly see why that is happening. So in early days, threat actors were using email phishing, which had some kind of links which either gave them access to their victims' credentials or compromised their machines. But with information security awareness and trainings, the success rate of this kind of exploitation went down, which actually forced threat actors to start using malicious documents which had macros in them. And we just saw in previous presentation that Microsoft decided to disable macros by default, so which actually impacted the success rate for these malicious documents. So threat actors started to look for applications or vulnerabilities in application where they can pass some form of input. So Outlook is actually a really good example for this. As long as your machine is connected to internet and you are receiving emails, threat actors can pass some form of input via email or some kind of meeting appointments. So without any further waiting, let's start looking at some of the vulnerabilities that were exploited. So first vulnerability we'll be discussing is elevation of privilege vulnerability in Outlook. This was a zero interaction vulnerability, which means no user interaction was required to exploit this vulnerability. And this was given a critical rating with CVSS of 9.8. This was patched in March this year, but soon there were reports that this patch has been bypassed. So Microsoft again patched that issue in May. But as per the write-ups or the blogs that are released by Microsoft, they were able to map the initial exploitation back to April 2022. So this is one of the timeline that was published online by some researchers. And as per this timeline, the original or the initial exploitation date that they were able to trace back was in March 2022, which was almost a year prior to this vulnerability was patched. We were able to verify parts of this timeline based on the hashes and samples that Microsoft shared and were available on VT. So a few things before we deep dive into this vulnerability. First is Microsoft publishes something called messaging APIs, which are basically APIs available for developers to create client applications which can handle emails and other calendar events. So these APIs are supported by multiple DLLs and systems that we can see on the screen. And for each Outlook event or email or a meeting that is created, their properties will be stored in messaging API properties, which can be then viewed using multiple open source tools that are available as of today. So this is a subset of some of the properties that are set when we create a meeting invite. And the bits highlighted here actually show the time zone, start time of the meeting and attendees who will be attending this meeting. Another concept we need to understand is Windows domain authentication. So NTLM is a protocol that has been discussed a lot in previous conferences actually. So NTLM is a three-way handshake authentication protocol. So the client sends a authentication request to the server responds with a challenge, and then client sends a response to that challenge to authenticate themselves. Another domain authentication protocol that is being used nowadays is Kerberos. This is mainly ticket based. So client authenticates to the server, mentioning which service it wants to access, and a ticket will be issued specifically for that service. With that information, now let's look at a demo on how this vulnerability exploitation takes place. Quick word on the setup here. There are multiple POCs available online which are using messaging APIs. But to keep things simple, we have written a POC in Python. We have an Exchange Server 2012 supporting our Outlook client. There are two attacker-controlled machines. One is SMB server, and the other one is a Kali Linux machine, which will have responder utility executing. So what you'll notice here is we have this Python script which is using COM objects to interact with Outlook application, and this is the code to create an appointment. So the current time on the machine, I'm not sure whether it's visible or not, is 6:03 a.m. So we are creating an appointment for 6:10 a.m. And as I mentioned, there are two attacker controlled machines. So we will go back to those machines, and on Kali Linux, we will be executing responder, which is basically a utility to do MITM attacks. And on the server controlled SMB machine, we will restart this Wireshark session. That is just for our understanding in this demo, and attackers don't have to do this. Now going back to our code, you will see that as soon as we'll execute this code, there will be some permissions required. That is mainly because we are using COM objects to interact. But as soon as these permissions are given, you will notice that a reminder is triggered. This is again the reminder for appointment that we set for 6:10 a.m. And if you might have noticed, on the backside in the Kali console, some text has appeared now. So now we'll go back to these two machines. So in Wireshark, what you will notice is as soon as the reminder was triggered, there are some SMB negotiation packets, basically to establish a SMB connection. And these negotiation packets will usually contain NTLM credentials or NTLM hashes. So our responder utility was able to capture that NTLM hash for the particular user. This NTLM hash can then either be relayed or forwarded to any other endpoint that accepts this, or if you have enough resources, you can actually try to brute force this. So what we just saw was an attacker can send appointment request to their victim, and those of us who have actually used Outlook, we know that even if you won't accept it, a reminder will be triggered for that event. So, and in our case, as soon as the reminder was triggered, we saw that SMB negotiation request was sent, which allowed our responder to capture the NTLM hashes, which can then be relayed to our target. So what is actually happening here? Turns out Outlook actually allows us to select a sound file which can be played when the reminder is triggered. And this is the dialog box which allows us to select that sound file. And in the backend, this is the messaging API property, reminder file parameter, which actually stores that path. So Outlook allows us to select this, and as soon as the reminder is triggered, this path is accessed. And if a value is set here, that sound file will be played. If not, there is a default sound file that is set and that will be played. The issue here is at no point in this process a verification is made to verify whether this path is local or remote. That exactly is the issue, and because of that, in our POC, we were able to replace this sound file path with a remote SMB server path. And at this point, this is how the reminder file parameter looked like. And as soon as the reminder was triggered, our system tried to establish a connection to this path. An interesting thing to note here is whenever this connection will be made, it will always have the NTLM credentials of the user that is logged into the machine, irrespective of the user who is logged into the Outlook. So as a result of that, we were able to gain NTLM credentials or NTLM hash of the administrator user who was logged into that machine. So when a reminder is triggered in Outlook, a call to play reminder sound API is made, which basically checks which sound file should be played, and then it creates a synchronous task to play that sound file. And in our demo, this was responsible to initiate the SMB connection. So to patch the issue, Microsoft added a call to is file zone local intranet or trusted function, and this function internally then called to map URL to zone function, which has been part of Windows for a long time. And back with IE, it used to actually check which zone the URL you are accessing belongs to. So now when a call to play reminder sound is made, a call is ultimately made to map URL to zone. And as you can see on your left hand side, this call is actually made way before the asynchronous task is created. Coming to the exploitation part, Microsoft actually published details of an attack that they were able to identify, where threat actors were actually able to gain access to NTLM hashes using this exploit, and they were able to relay them to Exchange EWS server, getting some form of access to users' mailboxes. This vulnerability in Exchange EWS was actually reported back in 2021, along with other Exchange server vulnerabilities. Now, before we deep dive into next vulnerability, let's first look at a demo on what is happening. So what you see here is that we have a mail with RTF attachment, and as soon as we try to preview this, it says that it's starting Microsoft Word Previewer. But as you will see in a moment, this actually crashes. So we had WinDBG configured in post-mortem debugging mode, which actually allowed us to analyze what was going on. And if you can notice here, it is actually trying to load WinWord. So what did we just saw? We saw a suspicious file as an attachment, and as soon as we tried to preview that file using one of the features in Outlook, it tried to load MS Word, and which crashed for some reason. So turns out this is a heap corruption vulnerability due to integer overflow in RTF parser of Microsoft Office. The researcher who reported this vulnerability actually published his own analysis as well as a small POC code on Twitter, and on Mastodon we were able to find a post with an account with same name claiming that this was actually identified years ago but reported just now, but we did not verify the authenticity of this post. And again, this was a critical vulnerability with CVSS of 9.8. So before we deep dive into this, a few basics that we need to understand. This is how a normal RTF file and a RTF file structure looks like. So RTF file structure is a flat file structure which has something called control words that start with /, and these are similar to markups in HTML. So these are used to define various sections, subsections, and their properties. And each control word will again have its own subset of control words. So to understand this vulnerability, we need to focus on this font table control word. And as you can guess by the name, it has something to do with loading the fonts that are referred to in this in the particular RTF document. So font table again has its own subset of control words, and the one that is of our interest for this vulnerability is font num or /f followed by a number, which is basically index of or the number of font which will be referred to in the document. So putting this together, we had two sentences in our RTF file. We have highlighted those two sentences in different colors. And both the fonts, like both the sentences are in different fonts, and wherever those fonts is defined, we have highlighted the font index /F0 and /F1 next to where font table is defined, as well as these are referred to where the sentences are then defined. So basically, this RTF file is loading and referring to 2 fonts. Now, what if we try to actually load thousands of fonts? Well, that exactly was the issue here. So the RTF that researcher published, we got our hands on that and we generated a RTF file. And when we looked at it, it was actually trying to load 32,760 fonts, which was basically causing this issue. So the RTF parser that supports Microsoft Office is www.lib.dll, and fsearch ftc map is responsible, or is the function responsible for handling this font table. So we generated this RTF file, we attached a debugger to our Outlook, and we tried to preview this RTF file again. So at one point, this is the code where we reached in fsearch ftc map. So the bits here highlighted in red and blue are move instructions along with sign extension, and the bits highlighted in purple, if you guys can actually recall your data structure basics, this is how we calculated address of a element or address of a memory location. So some data will be moved using move instructions, and then it will be returned to a memory location. So when we continued our debugging, we reached at this point. So point number 1 and 2 are the values of RCX and RDX that we have highlighted. And these 2 values will be used in the arithmetics that's happening in number 3. And ultimately EDX will be updated at number 4. So number 3 is where the integer overflow is actually happening. So once this happens, again, we'll refer the value that was updated in at number 4, and we will move it with sign extension in number 6 using move SXD instruction. So the value that you see at point number 7 is actually sign extended value of number 4 that we see here. And when this value will actually be used in the calculations that are happening in number 8, this will ultimately lead to access control violation. So this is how the stack trace looks like when this violation happens, ultimately leading to a call to report critical failure. So to patch this vulnerability, Microsoft actually added a call to safe int on overflow, which is basically an exception handling function. So what this did was, whenever there was an integer overflow condition, it gracefully handled the situation, and instead of application actually crashing, it simply restarted. So this is how the stack looks like when a call to this function is made. Now coming to the exploitation part, even with the POC that was released earlier, due to the complexity of setting data properly in the heap, we have not seen any working exploit for this vulnerability so far. And I actually say that with my own personal experience of exploiting this for this particular presentation. But RTF parser vulnerabilities and other Microsoft Office vulnerabilities being weaponized to exploit systems is not a new concept, and these are some of the examples of vulnerabilities that have been exploited by different threat actors in the past. So what's the outlook for the future? Well, back in 2021, we saw multiple vulnerabilities being reported in Exchange server. Some of these were even exploited in the wild back then. And as we saw, the Exchange EWS vulnerability, it's even getting exploited now. So the situation was a lot critical when these vulnerabilities were reported, and everyone paid attention to this on how quickly can we fix this. Coming to 2023, we have been following Outlook since March, and almost every month, one remote code execution vulnerability is being patched in Outlook. Interesting issue came up or Microsoft reported this back in July, that some threat actors were actually able to exploit the OVA, that is the web console for Exchange server, from where we can check our mail, and they were able to access mailboxes of different users. Microsoft has actually published another in-depth article about this, detailing how this attack happened last month in September. But the overall criticality of the issue with Outlook is not as serious as it was with Exchange server. And we believe the reason for this is that once you are able to compromise Exchange server, instantaneously you have access to the entire domain. But to get same level of access by compromising individual outlooks will actually take a lot of efforts. So that is why the situation is not considered as critical as it was back then. Coming to NTLM relay attacks, these are not new to Windows environment. There have been many in the past. We just saw Exchange EWS attack. Other than that, back in, I think 2 years back, there was a vulnerability titled Petit Potam, which actually allowed threat actors to get these NTLM hashes and relay them to Active Directory certificate server, and in some cases, giving those threat actors domain level access. So what are our recommendations here? So first is the most classic and cliche recommendation that I think everyone has made in all the presentations, to educate our users, to empower them, to give them a chance to differentiate between what is legitimate and what is malicious. One thing that I would like to add here is, other than just giving them theoretical understanding, we actually need to show them how these attacks are actually happening. So with that context, they will actually be able to understand more and act accordingly. Of course, this won't protect them against zero-day or zero interaction attacks, but the RTF parser vulnerability that we just saw, the macros issues that we have been dealing with for years, we will be able to protect against these. Now, in the starting of this presentation, I did mention that the success rate of these phishing kind of attacks is going down. But this is a news headline from September 13th, which shows that these are still happening. And now it's not only emails, but other form of communication are also involved in these phishing attacks. Next recommendation from our end is we need to ensure that the edge networking devices that we are working with are configured to block sensitive traffic flowing to untrusted network. And when we say untrusted network, we don't only mean internet, but also other segments of the network which actually don't have any, where the data does not need to be. So that needs to be ensured. Microsoft has been publishing or has actually published multiple articles on protecting against pass the hash attacks. And even after that, these NTLM relay kind of attacks are happening. So our recommendation would be just go through them, follow them. They have some interesting recommendations to make in case your environment is set up accordingly. Next is, we discussed about Windows authentications, NTLM and Kerberos. So NTLM has been used for decades, and there are multiple issues related with NTLM that have been reported for a long time. So I think this is the high time we finally decide to move towards Kerberos. Of course, initially there will be some issues with legacy systems that won't support Kerberos, but that is again something, once we plan to push everyone towards it over a period of time, that can be taken care of. So when Microsoft released information about this first CVE that we discussed, they actually released some details for organizations to look at if they were being targeted by this attack. So they, along with the guidance, they were actually able to, or they sent out a PowerShell script which was looking at this reminder file parameter that we discussed and giving out the information whether that value is actually set, and if it is set, to what value it is set to, whether that address is local or remote. Another interesting news came out start of September, where Microsoft actually claimed that they won't be supporting WordPad anymore, and it will be removed from upcoming versions of Windows. We believe this is actually not going to impact vulnerabilities in Microsoft Office's RTF parser, because that is entirely different from this. But one thing that could happen is what is actually happening with MS HTML. So it was originally there to support IE, but once IE went out, it stayed back to support Microsoft Office applications, and every now and then we see vulnerabilities being reported and exploited in that. So that is something that could happen with RTF parser in Office, and we need to look out for that. Last but most important part is we as a security product vendors, we need to be in a position where we can actively flag vulnerable component in our customer's environment. So far, for I'm not sure how many years we have been, releasing advisories that this is vulnerable, patch this is vulnerable, patch that, but that is not happening. But I'm sure if a customer sees on his machine a flash or a red alert saying that this is vulnerable, you will be attacked because of this, they will be in a position to fix that. So we started this discussion with discussing two vulnerabilities, which were two different attack vectors. One was directly exploiting a vulnerability in Outlook, and second one was actually using a feature in Outlook to exploit a vulnerability in other MS Office application. And we are ending this with some of the recommendations to protect our customers against that. So that's all for this presentation for now. Thank you very much.